Hey everyone, we're going to be talking about applications of the unit circle. So let's take a look at number 3a on page 202. Find sine theta if cosine theta is equal to 2/3 and theta is in between 0 and pi over 2. So you can remember from class that if you have a unit circle where radius is 1, and if you're given an angle theta, we know that this side is sine theta because it's the opposite over hypotenuse. And the hypotenuse here is 1. Let's erase this here. And this side is cosine theta, since it's adjacent over hypotenuse. And again, the hypotenuse is 1. So we can see using the Pythagorean theorem that sine squared theta plus cosine squared theta, the two legs of any right triangle, is equal to, squared is equal to the hypotenuse square, which is here, is equal to 1 squared, or 1. So let's go ahead and use this formula to find sine theta. So I'm going to plug in 2/3 for cosine theta, but we have to square it. Is equal to 1. Okay, so then if I multiply out, I get plus 4/9 is equal to 1. Subtract 4/9 from both sides, and I get sine squared theta equals 5/9. The inverse of taking the square of a number is to take square root. So sine of theta is equal to square root of 5 over 3, or when we know there's a positive and a negative root. Now we have to take the second piece of information here, that theta is in between 0 and pi over 2, which means it's in the first quadrant. In the first quadrant, sine theta is the y-coordinate, and in this case, in the y-coordinate, it has to be greater than 0. So in this case, we know that sine of theta can only be the positive root. Okay. Now in class, for number 1, when we took the square root of, it was sine squared theta, you need both the positive and the negative root because there are no restrictions on theta. But here there is a restriction, so therefore you only have the positive root. Okay, let's take a look at number 4, and you're going to be asked to do A and B, so let's look at C. Okay. If sine x is equal to -1 over square root of 3, and x is in between pi and 3 pi over 2, we want to find what tan x is. Now, of course, we know tan x is equal to sine x over cosine x. Now, we're given sine x, so we need to find cosine x. So we're going to use the trig identity again. Sine squared theta, which is here -1 over square root of 3 squared, plus cosine square, in this case actually we're talking about x's, is equal to 1. So this is going to be equal to -1 times -1 is 1, square root of 3 times square root of 3 is 3, plus cosine square x equals 1. Subtract 1/3 from both sides and you get 2/3. Then of course you have to take the square root and you get cosine x is equal to square root of 2 over 3. Okay? And there's a positive and a negative root. Now, we can go ahead and rationalize the denominator, and then we get positive or negative square root of 6 over 3. So x is in between pi and 3 pi over 2, so that would be in the third quadrant here. Okay, so 180 and 270 degrees. It's in the third quadrant, and in the third quadrant, the cosine is the x-coordinate, and here the x-coordinate has to be less than 0, so we just want the negative square root of 6 over 3. Okay, so if that's equal to cosine of x, we want to know what tan x is. So tan x is sine x, which was given as negative 1 over square root of 3. Cosine x, we can go ahead and actually write it before it's rationalized, which, well, let's write it just as we have it. Negative square root of 6 over 3. Okay, a negative divided by a negative is a positive. So let's write it as a multiplication problem. 1 over square root of 3 divided by a number is the same thing as times its reciprocal. This number right here is a 3. Okay, so we have 3 over square root of 6, and that's going to equal 3 over square root of 18, and we can simplify that as square root of 9 times square root of 2, and 3, the square root of 9 is 3, and so the 3's cancel, and you get 1 over square root of 2. Or if you rationalize it, that's square root of 2 over 2. Okay. Okay, let's go ahead and take a look at page 204 for number 1. We're to find 2 angles theta on the unit circle, and theta has to be in between 0 or 2 pi or equal to 0 or 2 pi. So in other words, it's within 1 revolution of the unit circle, between 0 and 360 degrees. So the first thing you're going to do is that you're given cosine theta is equal to 0.83. So in order to find theta, you do the inverse, which is to find the arc cosine, or cosine to, and it looks like to the negative 1, 0.83. So I'm going to write that down here. Cosine of 0.83, cosine, arc cosine. So this is a TI Inspire, and it was a 0.83. 0.83. Enter, and we get 0.592. So let's write that down. So theta equals 0.592. So we're going to go ahead and take a look at these trig identities. We already have one value of theta, but we need another value of theta. So we know that cosine of theta is equal to cosine of 2 pi minus theta. So these two things are being equal. We know that the cosine of theta is equal to 0.83. Cosine 2 pi minus theta would also equal 0.83. And so therefore we're going to figure out that another value for theta could be 2 pi minus 0.592. If we plug that into the calculator, 2 pi minus 0.592, see here, 2, there it is, minus 0.592, and we want it to be between 0 and about 6.28, and it is 5.69, so I can write down 5.69. And the restriction on theta is it has to be in between 0 and 2 pi, and 2 pi is approximately 6.28. So we have two angles. We have 0.592 and 5.69. Okay, let's take a look at number 1H. Tan theta is equal to 20.2. So in order to get theta, we have to get the inverse of tan, or the arctan, of 20.2. Okay, so let's use our calculator to do that. So arctan of 20.2, and that's equal to 1.52, approximately. Okay, so now we can use this formula right here, this identity. Tan pi plus theta is equal to tan theta. So these we have is 20.2. Both if this one is equal to 20.2, so is tan pi plus theta is also equal to 20.2. So therefore pi plus theta is about pi plus our theta here is 1.52, and pi plus 1.52, let's use your calculator. Pi plus 1.52, and that is approximately 4.66. Okay, and here are our two values for theta. They're both in between 0 and 6.28. Okay, let's take a look at number 2. Sine of theta is equal to negative 0.421. So we have theta is equal to arc sine of negative 0.421. So sine negative of arc sine of negative 4.421. Negative 0.421. Okay, and then we have enter. Negative 0.435 is our theta. But we want two values which are in between 0 and 2 pi. So we're going to need to use our trig identity probably twice here. So the first one says that sine of pi minus theta is equal to sine of theta. And so we're going to have pi minus theta be is approximately pi minus theta negative 0.35. Okay, so pi minus negative 0.35, see here, pi, oops, minus, negative is the same thing as plus, 0.435, enter 3.58. But we need another value of theta, which is in between 0 and 6.28. And if I add another pi to this, this is going to get me over 6.28. So I have to think of another identity. And it's not written here, but we know that it was written in your foldable. Sine of theta is periodic every 2 pi. So I can write it like this. Okay? So every time it goes around one revolution, okay, we have an angle, okay, in a unit circle, okay, and if it goes around 2 pi times, it ends up at the same point, the periodicity of trigonometric functions. So I'm going to use that, and we have 2 pi plus theta is equal to 2 pi approximately, because we're rounding, plus negative 0.35, which is our theta, and that's going to be 2 pi minus 0.435. So let's go back here, 2 pi minus 0.435, and we get 5.85. And that is also less than 2 pi, which is about 6.28. So here are two values between 0 and 6.28. So when you do the other problems, you're going to have to take a look at these identities, okay, and choose the one that allows you to get a theta, which is between 0 and 6.28. Okay, so sometimes you're going to take the theta, subtract it from pi if you're talking about sine, or you can take theta and add 2 pi. And just remember that the cosine is also, let me erase this, periodic, and similarly to the sine, cosine is also periodic every 2 pi revolutions. I'm sorry, every 2 pi radians, which is 1 revolution. Alright, I hope that helps, and let me know if you have any questions.